So in this latest video looking at angles, we'll be focusing on angles in polygons and looking at interior and exterior angles. Now we know that the total sum of angles inside a triangle adds up to 180. And if you're not too sure, then I will include a link in the video for you to watch the previous video that covers this. Now, as a triangle can also uncommonly known as a three-sided polygon, that we can use this knowledge to work out what the total sum of angles inside any polygon is going to be. Now, it doesn't really matter whether that polygon is regular or irregular, the total sum of the angles will be the same based upon how many sides that it has got. So by selecting a vertex, which is a more mathematical name for a point, let's just make sure everything's on the screen, there we go, on a polygon, and then joining all the other vertices to this vertex with straight lines, we can see multiple triangles. So for example, we start off with a four-sided shape. Now it doesn't matter what four-sided shape that is. So here I'm going to pick a corner or a vertex, and I'm going to join a line to each of the other points. And by doing that with straight lines, or what resembles a straight line, you can see that I've got a number of triangles. So here I've got one triangle and I've got two triangles. Now if I pick a five-sided shape, so if I pick this vertex, I'm going to draw a straight line to all the other corners of that shape, then what I produce is three triangles. So 1, 2, 3. And if I pick a six-sided shape, so again just any hexagon, and I have a straight line that joins from one point to all the others with straight lines, you can see here that I've got four triangles. Oh, I don't know what's going on there, so let's just quickly get rid of that. So here I've got 2, 3 and 4. And if I go in an eight-sided shape, so again just pick a corner and I just draw straight lines to each of the other points, and you can see I've got 1, 2, 3, 4, 5, 6 triangles. Now if I then add up, now each of the triangles, as I've already mentioned, adds up to 180, I can then work out what the total sum of angles is going to be. Now I would strongly recommend that you make a note of this particular table, but revising this particular table is again a lot for you to remember. So what is important is you know how to actually get the angles. So although it's really important you know the names of the regular polygons or typical polygons that you can have, and also knowing how many sides it's got, in terms of the sum of angles, I'll probably say it's difficult to remember all of these, let's say 7 numbers, but if you can remember how to actually work it out, then that's the best thing. So the important thing is first of all working out how many triangles it's got. Now if you look at the number of sides a shape has got, then the number of internal triangles drawn in exactly the same way as what I've drawn previously is basically a number that is 2 less. And then once we know how many triangles there are, if we multiply that by 180, then we get our total sum of angles, which adds up to these values here. So a triangle, any triangle, doesn't matter whether it's a scalene, isosceles, equilateral or an isosceles triangle, the internal angles are all going to add up to 180. In any quadrilateral, so we're talking about squares, rectangles, trapezium, parallelograms, rhombuses, any four-sided shape, the internal angles are going to all add up to 360. With a pentagon or a five-sided shape, they're going to add up to 540. For a hexagon, and I mean any six-sided shape, is going to add up to 720. For a heptagon, 900. Octagon, 1080. For a nonagon, which is a nine-sided shape, it's going to be 1260. For a decagon, it's going to be 1440. And as I mentioned, the key thing is to work out what the total sum of angles it's going to be, is first of all work out how many triangles they're going to be. So in other words, just take the number of sides, take away from 2, and then multiply that answer by 180, and you will have your total sum of angles. So let's say, for example, a question asked me to work out the total sum of angles inside let's go for a 15-sided shape. So what I'd have to do here is I'd do 15 take away 2. So 15 take away 2 is 13. So then that'll tell me how many triangles there are. Now if each triangle is worth 180 degrees, then I do 13 times 180. And again, that's when I reach my calculator and do 13 times 180. So the total sum of angles is going to be 2,340 degrees. Now note that you're not actually working out the size of one angle, because obviously you know that one angle can only be between 100 and 360, but this is all the angles added together. So in this particular shape, it would be the total sum of all 15 angles that are inside that 15-sided shape would come up to a total of 2,340. Now the next thing we move on to is what we call interior angles. Now if a polygon is regular, then not only are all the sides equal length, but all interior angles are going to be the same. So if all angles are the same, then to work out the interior angle of a regular polygon, we simply first work out the total sum of angles and then divide this by the number of sides or the number of angles the polygon has. Now in terms of this, apart from this shape here, which represents a rectangle, and now we can see we've got a regular quadrilateral, which is also known as a square. So from this, what we're going to do is we can work out what size. If we've got a regular shape, then what it is there a quicker way of working out what the size of these angles here are? Now with a four-sided shape, that's pretty obvious. It's going to be 90 for a square. For a pentagon, it's a case of all of these angles are going to be the same, so what is it going to be? For a hexagon, we've got all of these angles are going to be the same. And for an 8-sided shape, which is an octagon, what are these angles going to be? This octagon definitely doesn't look regular, but if it was, then it would be that kind of shape. So let's have a look at another table then. So to work out what the interior angle is going to be for a regular shape, and it's important that we establish the word regular, because these are not all the interior angles of any polygon, it's only of regular polygons. So in an equilateral triangle, I should say, which is a regular triangle, then each angle is going to add up to 60. Now here, the first thing we need to do is work out what the total, from the number of sides, we can then work out what the total number of angles is going to be, and that's using the previous method that we showed earlier. So in a triangle, they all add up to 180. There's 3 angles in a triangle, so we do 180 divided by 3, which gives me 60 degrees. In a 4-sided shape or regular quadrilateral, which is known as a square, here I've got all the angles are going to add up to 360. So I've got 4 angles, so it's going to be 360 divided by 4, which gives me an answer of 90. In a pentagon, the total sum of angles is 540. So in a regular pentagon, I divide that by 5 because I'm going to have 5 angles, and they will add up to 108. For a 6-sided shape, for a hexagon, the interior angles are going to all add up to 720. Divide that by 6, and that will give me 120, and so forth. Now, as I said, you don't need to remember every single one of these numbers. What will make your revision a lot easier is if you remember how to calculate these values. So from this, hopefully what you should be able to know is how many sides a shape has got, which is just called n. Then we work out the number of triangles it's going to be. Of triangles, which is always a number 2 less than that. Then we multiply that by 180 degrees, and that will give us our total. So this formula gives me my total. Now then, what I then need to do is with that total, so the total sum, if I divide that by the number of sides, then that will give me each of these numbers, which is what I'm wanting, so which is the size of the interior angle. So what is important is if you remember these steps here. Now obviously recognizing the name of the shapes, which is also important, because a typical question might ask you is what is the interior angle of a regular nonagon? So what you do then is you'd work out how many triangles there are, 7, times that by 180, which then gives us the total sum of angles, which in this case is 1260. Divide that by the number of angles we've got, which will give me my answer of 140 degrees. And that would be a typical question that you would get in an exam. Now, if we have interior angles, then exterior angles also exist. Now, an exterior angle is an angle between any side of the shape and the line extended from the next side. So as you can see on this pentagon, that I've highlighted what each of the exterior angles are going to be. So if I just first of all make a note of one of the interior angles, so this here is my interior angle, then this little blue angle is going to be my what we call the exterior angle. And the important thing to note is that the interior angle plus the exterior angle is always going to add up to 180 because they are on a flat line. Now, in terms of recognizing where the other exterior angles are going to be, well, imagine what you need to do is kind of imagine like a Catherine wheel firework, or look at it as rotation. So for example, if I note that this is my first exterior angle that I've spotted, then if I rotate this shape, then that line would then produce where this green line is going to be. If I rotate that again, then the yellow line is where that line is going to be. And if I rotate that any further, then what colour are we going for? Let's go for purple. Then that would be this purple line, and then it would then produce this pink line. So as you can see, we've got 5 interior angles, and therefore we've got 5 exterior angles. Now, although the size of those angles will be dependent on how many sides that we've got, the most important rules that you need to remember is that the interior angle plus the exterior angle will always add up to 180 degrees, and that all exterior angles on a regular polygon will add up to 360 degrees. So if I add up all of those blue angles, in fact any exterior angle on a polygon, that they will all add up to 360. So to work out what the exterior angle is, there's several ways in which you can do this. Now, to find the size of an exterior angle on a regular polygon, you can either remember that the exterior angle is 180 degrees take away the interior angle. And again, if you're not too sure how you work out the interior angle, I recommend you just watch the video again, or it's earlier on in the video. Or we can use this formula here, and which is these two things are exactly the same. So this bit here, if I just highlight it in this little pink bubble, is basically the formula to work out what the interior angle is going to be. Let's make that a little bit neater. So there we go. So that's the interior angle. So this formula here and this formula here are exactly the same. A much easier way of remembering how to work out the exterior angle is if you know how many sides the shape has got, then you can then use this formula here. So for example, if I wanted to work out the exterior angle of a nonagon, then what I need to do is recognize that a nonagon has got 9 sides. So the exterior angle is going to be 360 divided by 9, which gives me an answer of 40 degrees. And there would be my answer. So the exterior angle would be 40 degrees. So now let's have a look at some example questions. And these are all taken from, let's say, something you can typically find in any sort of either KS3 or GCSE exam. So the question says that the diagram shows an irregular octagon. So in other words, irregular means that the sides are different sides, different lengths, I should say. And the question is asking us to work out the sum of the interior angles. Now, the important thing with this question is it's asking for the sum of the interior angles, which basically means the total of all interior angles. So what the question is asking me is to work out this angle plus this one, plus this one, plus that one, plus this one, plus this one, plus that one, plus that. I also know that an octagon has got 8 sides. So again, if I forget the formula or I'm not too sure how to work this out, I pick a point, which I'm just going to go for this point, and I draw a line to each of the other vertices, or in other words, the other corners. Now by doing so, what I've done is I've split this shape into triangles. So if I count the number of triangles, I've got 1, 2, 3, 4, 5, 6. So the total sum of angles is going to be 6 times 180. So if I work that out on my calculator, 6 times 180, that gives me a total answer of 1080 degrees. Another way of doing it, if you remember the formula, which is 180 times n minus 2, n being the number of sides. So if to work using the formula, do 180 times 6, no, not 6, that's the answer. Let's get rid of that. And it's going to be 8 because n is the number of sides. and an octagon has got 8 sides, so it's going to be 8 take away 2, so that's going to be 180 times 6, which gives me the same answer of 1080 degrees. So it doesn't really matter which way you do it. If you learn the formula, excellent. If you forget, as long as you learn the method of picking any point, drawing straight lines to all the other points, working out how many triangles there are, multiplying the number of triangles by 180, you get the total sum of angles, which we have here. So let's have a look at question 2. Now question 2 is very, very similar to question 1. It says work out the sum of the interior angles of a pentagon. So again, we're looking for the total and of the interior angles of a pentagon. So again, let me just write down the key aspects. We're looking for the total, we're looking for interior angles, and a pentagon has got 5 sides. Now what's different about this is that we don't have a diagram. Now if that is going to be a bit of a hindrance to you, then just draw any 5-sided shape. It doesn't need to worry about the shape. So if I just draw 5-sided shape, looks like this, doesn't really matter because it doesn't need to be regular. Pick a point, draw a line to all the other points, and you can see here that I've got 3 triangles. So I'm going to do 3 times 180, and again if I type that into my calculator or work it out, it's not a problem, it comes up to a total of 540 degrees. Alternately, you could use the formula, so it's 180 times n minus 2. The number of sides in a pentagon is 5, so I've got 180 times 5 take away, keep saying the answer, I don't know why, it's annoying. So here I've got 5 minus 2, which is 180 times 3, which again gives me the answer of 540 degrees. Now again, if this was on a non-calculator paper, then all I need to do is do 180 times 3, work it out, and I should get the answer of 540. So let's have a look at question 3. So question 3 says the diagram shows a regular dodecagon. Work out the size of one of the interior angles. So what the question is asking me is to work out what this size angle here is. Now a dodecagon has got 12 sides. Now if I don't know that, well, this is why they've given me a picture. All I need to do is just count the number of sides, and that should add up to 12. So the first thing I need to do is work out what the total sum of angles is going to be. So to do that, again, I pick a point and draw my lines going forth like so, and I should work out that there are 10 triangles. So I'm going to do 10 times 180, which gives me an answer of 1800 degrees. So now what I need to do is then divide this by the number of sides, which in this case is 12. So I'm going to do 1800 divided by 12. And again, you can either, if it's non-calculator, you just have to do a bit of long division. If it's on a calculator, it's dead easy. Just simply work that out, and I work out that each angle is 150 degrees. Now, does that look correct? Well, yeah, because I'm expecting an obtuse angle, and I've got in my answer an obtuse angle. So again, that's looking absolutely fine. Now with question 4, it says work out the size of one interior angle of a regular octagon. So again, very, very similar. This time we've just haven't got a diagram. So again, your options are either draw an octagon, which I'll admit is probably not the easiest, but just to count 1, 2, 3, 4, 5, 6, 7, 8. That's absolutely fine. So again, pick a point, draw a line. So all you're interested in is how many triangles it's got. And you should find that there are 6 triangles. So here we're going to do 6 times 180. So 6 times 180 equals 1080. And then going to divide 1080 divided by the number of sides, which is 8. And so do 1080 divided by 8 gives me an answer of 135 degrees. Now does that look correct? Yes, because again I'm expecting an obtuse angle and I've got an obtuse answer. That's absolutely fine. Again, if I wanted to use the formula, I do 180 times the number of sides, which is 8, take away 2, which gives me 180 times 6, which gives me the exact same answer. Let's have a look at question 5. So question 5 says the diagram shows a regular decagon. And the question is asking us work out the size of one exterior angle. Now, as I said, there are several ways in which you can do this. Now, a decagon has got 10 sides. So what I could do is I could either work out what an interior angle is going to be, or I could remember that all exterior angles, so all exterior angles add up to 360 degrees. So every single exterior angle is going to add up to 360 degrees. So here if I do 360 divided by 10, because I've got 10 exterior angles, and that's going to give me an answer of 36 degrees, and there is my final answer. Now if I did work out what the interior angle is going to be, which again is not a problem, so here I'm going to have 8 triangles, so I'm going to do 8 times 180, which gives me an answer of 1440. Then if I do 1440 divided by the number of sides, which is 10, I get 144. So this angle here is 144 degrees. So to work out the size of this blue angle, all I need to do is 180 minus 144, which also gives me 36 degrees. So it really does depend on what information you'll be given and what you remember in terms of method to work it out. But I certainly would recommend that you know both. So let's have a look at question 6. So question 6 which says work out the exterior angle of a regular hexagon. So a hexagon has got 6 sides. So again, I could work it out in one or two ways. If I remember that all exterior angles add up to 360, and I've got 6 exterior angles, I just do 360 divided by 6, which is going to give me an answer of 60 degrees. Alternatively, I could work out the total sum. So in a hexagon, I'm going to have 4 triangles. It's always 2 less than the number of sides, so I'm going to have 4 times 180, which is 720. So an interior angle is going to be 720 divided by 6, which gives me an answer of 120. And then I need to do 180 minus 120 equals 60, and there is my final answer, because again an exterior angle and an interior angle are all on a straight line, so I just need to take away from 180, so either method is going to be absolutely fine. So let's have a look at question 7. So question 7 says the diagram shows a regular pentagon with center O, and the question is asking us to work out the size of angle X. Now it's not asking us to work out any other angle apart from just this one on this particular triangle. Now it's depending on how you want to work this out. Well, a couple of things that you should be able to spot. Like for example, X is half the size of an interior angle. So if I highlight this interior angle, this one here, then this angle X is half of that. So that's going to be X, that's going to be X. And we can do that. So we can work out what the total sum of angles in a pentagon is going to be, well, it's going to be how many triangles there are. Now note, it's not the triangles you see here, it's the number of triangles when you split this shape up. So it's going to have 3 triangles. It's going to be 3 times 180, which gives me an answer of 540. Now if I then do that, an interior angle is going to be 540 divided by 5, and that gives me an answer of 108. So this angle here is 108, and if X is half of that, then X is going to equal 108 divided by 2, which gives me an answer of 54 degrees. Now another way of looking at this is, now if I just get rid of all these markings, and that's just one way of working this out. Another way of working out is thinking, right, okay, well all of these angles at the center all add up to 360 because they're angles around a point. So one of these angles is going to be 360 divided by 5, and I work that out to be 72 degrees. So this angle here, so if I just get rid of this circle, so what I've then worked out is that this angle here is 72 degrees. Now another thing that I should be able to spot is that this triangle is an isosceles triangle, because all the triangles are going to be the same, and if this length from the center to each of the vertices are going to be the same, then therefore that is going to be a isosceles triangle. Now from this I know that this angle here is also going to be x, so I know that 180 minus 72 is going to equal 2x. Now if I do 180 take away 72, I get 108 equals 2x, and so again 54 equals x, and I've got my answer, which is exactly the same as what I got originally. So there may be more than one or different ways of working out these types of angles, but the answer, if correct, will definitely be the same. And it's always important that you do show you're working out either on the diagram or by writing it down in steps. So let's have a look at our last example. So it says here that two identical regular hexagons are joined together as shown in the diagram, and the question is asking us to work out the size of angle x. Now to work out what angle x is, it would make this question a lot easier as if I knew what this angle here is, and I also knew what this angle here was. Now the orange angle that I've highlighted and the green angle I've highlighted are both going to be the same because they're both interior angles. So this angle here is the interior angle of a regular hexagon. So again, to work out the size of that angle, what I need to do is work out the total sum, which is going to be, well, how many triangles are there in a hexagon? Well, it's a six-sided shape, so it's going to have 4 triangles. So it's going to be 4 times 180, which is going to give me 720. So then the interior angle is going to be 720 divided by the number of sides, which is 6, and 720 divided by 6 gives me 120. So that means that if I just get rid of all of these markings just to make it a little bit easier to see, so that means that this angle here is 120 and this angle here is 120. And so to work out what angle x is, I need to do 360 minus 120 minus 120, which gives me the answer of, surprise surprise, 120 degrees, and there is my final answer. Another way you could answer this question, so let me just get rid of all of this, is to see x as 2 exterior angles. So here, if I note that x is 2 exterior angles, so if I split this up, that x is equal to 2 exterior angles. Now to work out the exterior angle on a regular hexagon, then all I need to do is do 360 divided by the number of sides that it's got, which in this case is going to be 6, which is going to be 60 degrees. So that means that this angle here is going to be 60 and this angle here is going to be 60. So to work out what x is, all I've got to do is just simply add those two up, and I get the exact same answer of 120. As I said, so there's different ways in which you can work it out based on the knowledge that we've covered in this video, but as long as you're showing you're clear working out either on the diagram or by writing it down, you should get the full marks in the question. Now we'll put some practice questions in the description below for you to practice everything that's covered in this video.